Zombie apocalypse. Zombie apocalypse.
Good day, MEI students who are currently taking MEIE TLE 210, which is all about electrical and electronics technology. By the way, this is Sir Ken G.E. Merenciano, your course facilitator. Maybe some of you are wondering why Sir Kenji decided to record and uploaded this video. Um, Plus, we will not be having our synchronous meeting scheduled as scheduled today because we have uh, a meeting with the uh, department chairs and program advisors concerning on the preparation for enrollment for the start of first sem 2022 to 2023 this coming August, as well as uh, in preparation also for the commence 50, if I'm not mistaken, 52nd or 53rd commencement exercises, uh, uh, which is scheduled on Monday, and that will be on July 11th. And since there are lots of meetings scheduled, that's why I decided to record and upload this video as your perusal so that you can catch up or cope with these lessons and activities relevant to this course. Okay. So if we can have a short of a recap, one of the topics were presented pertains to quantities of charge, and I mentioned from the previous video that we will continue about another type of charge, which is uh which is all about power. Okay, so without further ado, I'll show you the material and give you an, uh, a presentation about power and how to compute for electrical power uh, using the Ohm's law and sample problems, and I'll be providing you exercises. Okay, so here it is. So class, as I've said, our next topic is all about power. So in continuation to the fundamental quantities of charge. So before we dig deeper and discuss this quantity, I'll show you a picture and try to guess this famous or notable quote from a movie. Okay, so I think you know this Marvel character, a well-known um, uh, superhero. So if you're watching this video, can you guess this phrase? So great blank comes great blank. If we're going to unlock these two terms pertains to with great power comes great responsibility. So I think uh, uh, this phrase, uh, um, I think I'm guessing 4 out of 5 people would attribute to Parker. I mean, the uncle of Peter Parker. That's the protagonist or the hero or the Spider-Man. This quote or saying came from the Spider-Man movies in comic books. But if we're going to research the origin of this quote, it can be attributed to a host of historically significant events and people. I think this quote were used by Voltaire, Winston Churchill, and both presidents like Theodore, the two Roosevelts. Okay, it's not the Spider-Man. So sorry, Spidey. It's not from the movie Spider-Man who really originated this saying. Okay, this quotes attributed way back, if we're going to trace the history, from a French Revolution. It's an ancient adage, at least as old as first century BC. So enough with the history, enough with the saying. But in the context of electricity and electronics, uh, it's different. With great power, we're not referring to responsibility, but we're talking about electricity. So can you anticipate your coming bill is this mid of July? So that is what is meant by this uh, quote. With great power comes great responsibility. Okay, so let us proceed to let us discuss what is power is all about. Okay, so power, from its definition, it refers to energy. Okay, when you say energy, it is your ability or capacity to do work. But here in physics, power uh, means it is the amount of energy transferred or converted per unit time. So, in other words, it is the rate at which work is done in a given period or time. So, if you're going to express this mathematically, power is equivalent to work over time ratio. So, meaning to say, power or P is the symbol is equals to what? Or work, I'm sorry, work over time, or W over T. Okay. Since we know that the unit of measure for voltage is volts, current is ampere, uh, resistance is ohms. The unit of power, or the unit of measure for power, is watt. Okay. It has also an origin. The name Watt came from a scientist named James Watt, wherein Watt is equal to 1 joule per second. Joule also is a name of a scientist, or if I'm mistaken, it is some a scientist or an inventor. Okay. Um, to understand power, uh, usually when we buy appliances, or the appliances you have at home can be measured in power. Like for example, uh, window type or split type of aircon has this corresponding horsepower. So other common and traditional measures are horsepower for power, comparing to the power of a horse, which is equivalent to one mechanical horsepower is equals to 745.7 watts. Okay, so that is the meaning of power. It is the rate at which work is done, or the amount of energy transferred. Unit of power niya is watt. Okay, so let us proceed to the next. Uh, Again, if you can still recall, I presented or discussed with you the Ohm's law triangle. So it's one way to easily determine the value of charge based on the given two charges also, or finding the solution or the value based on the two mentioned charges. So if we have the Ohm's law triangle, we also have the power triangle. So if is it is represented by PIB or pi in some books or references. Okay. So um here, if you want to know the value of power, you have to cover this one again. Okay? So that you are guided. So P, okay, P is equivalent to current and voltage. So power is equals to I times B, or current times voltage. So that's how you're going to determine the value of power based on the two charges. Next, if you're going to look for uh, if the current is missing or I is missing, the formula is I is equals to power over voltage, or current is equals to P over B. Likewise, also, if voltage is missing, the formula for finding voltage is V is equals to P over I, or voltage is equals to um, power over current. Okay? That is our power triangle. Here is a pie or pear chart. If you will observe, uh, this power triangle has limitations. Supposed to be, you're going to determine the value. Suppose like this, you're going to determine the value of power, but the given charges are current and resistance. So here, using the pie or the pie chart or the pear chart, this is the power, voltage, current, and resistance calculator. So, for example, the given are resistance and current. If you're going to determine the value of power, P is equals to I squared times R. Okay? If if another problem is if voltage and resistance are given, the formula for finding power is P is equals to voltage squared or E squared over R, or resistance. Okay? So this is the it's a more complex, but you can easily trace or determine the formula based out of this chart. Okay? Here's another way of determining the values and getting the correct charge. Okay, so we have this Ohm's law matrix or table that represents the known values and and the four charges. So let's say in a diagram, the given are current and resistance, and you need to get the value of the voltage. So the formula is B is equals to I times R. But if power is missing, the formula that you're going to use is P, or power is equivalent to current squared times R, or resistance. Okay, let's say voltage and current, power is missing. So the formula that you're going to use is P is equals to voltage times current. So that is how you use the Ohm's law matrix or table. Now let us proceed to sample problem. So based on this diagram, the given are, or the parameters are, 24 volts, I is equivalent to 2 amperes, R is 12 ohms. So the power is unknown. So we're going to solve for power. So based on the Ohm's law matrix, based on the pie chart, or based on the power triangle, the formula for finding power, since these two charges are given, P is equals to I times B, or power is equivalent to current times voltage. So the actual value is P is equals to 2 amperes multiplied by 24 volts. So what you will get is 48 watts. So that is the value of power based on this diagram. Okay. So class, please be guided with the table, with the chart, and the triangle for you to determine. What important is you know the formula, you are guided by the charts and triangle. It would be easy for you to arrive with a solution and the correct answer, or the correct fundamental charges. So here's another problem. So you need to calculate the power of an electrical circuit consisting of resistance, which is 3 ohms, and a 4 ampere current that is flowing through the circuit. So the parameters are current is equals to 4 amperes and R is equals to 3 ohms. So the electric formula or the electric power formula is P is equals to I squared times R. So if you're going to get the correct value for that, based on the two parameters, you will get 4 squared times 3. So what you're going to do is to multiply 4 times 4 and you will arrive to 16 and you will multiply again by 3. Okay? So you will get um, 48 watts. Plus, don't forget to uh, to uh, to be familiarized with the unit of measure. Sometimes you get the correct solution as well as the correct answer, but you neglect the or you forgot to to give the correct unit of measure or value. Okay. So again, the answer is 48 watts since we're looking for power. Okay. So another problem. Calculate the electric current of a 10-watt lamp designed for 12 volts. So what are the parameters or the known? So we have power or P, which equivalent to 10 watts. Voltage, we have the 220 volts. And what we are looking for is the electric current or the unknown. Solution. Lamp power is equivalent to 10 watt, which is equals to 10 joules per second. So, to understand, the equation below shows the relationship between electric power, potential or the voltage, and electric current, which is stated in the formula. P is equals to voltage times current. But we are looking for, or so meaning to say, looking for electric current. So I is equals to P over V is equals to 10 over 100 or over 220 or 1 over 22 and you will get 0.045 ampere. So that is the value for current since what is lacking is the uh, uh, since what we are looking for is the electric current. And okay, so that's how you get the value of current. Okay? So another problem, calculate the electric current of a 3 kilowatt designed for 150 volts. So the given, we have 3 kilowatt which is equivalent to 3,000 watts. So that's for power or electric power. Plus, can you still remember um, the kilo and mega based on the sample problems that were mentioned in the video about kilo and mega? So in electricity and electronics, kilo represents thousand and mega, it means millions. So since the given is 3 kilowatts, so you have to convert that into 3,000 watts. And we have the voltage which is equals to or um, um, which is 150 volts. So we're looking for I or electric current. So the solution is the relation of electric power, electric potential, and electric current, which is stipulated below. So P is equals to voltage times current. The electric current is um, I is equals to P over B. So if for the actual value, I is equals to 3,000 watts over 150 volts. And you will get I is equals to 20 amperes. So that's the correct answer for this problem. Now, this time, you're going to give me the answer with um, solutions. Okay? So, after watching this video, kindly comment your answers or come up with its solution, okay, based on these three problems. So I'll be giving you uh, uh, time for you to watch this video, and later on, you're going to provide me your answers. So I better uh, switch off my camera first so you can read the third statement or the third problem. So kindly watch this, kindly observe or look at this problem. Again, I un what do you call this? I muted the video. I'm sorry, I muted uh the recording. So again, if you are listening or watching this video, thanks for your time, or thank you for sparing your time. And as I've said, since I muted the microphone, if you have questions or clarifications about these lessons or topics or about the activity, feel free to contact me. Can you look at the comments, the details, contact details. So, class, thank you for listening. And again, based on the exercises given or the problems provided, kindly give me your answers or with solution by posting your comments uh, from this video. For the last time, thank you for listening. Um, I hope you're doing fine. The comfort of your homes or your workstations or anywhere while watching this video. And as what I always say, keep safe always.
Zombie apocalypse.